one of the talks that I submitted, and no good deed goes unpunished, so this one got selected. So I take another and another presentation. This will be fast, a little bit more, so let's get on this one. Find my mouse there. Actually, what I will much more about in this talk is I'm going to talk about the journey of Softraid, how we got where we are today, and why we went down this path. Code's been around for 2005, I think, is when the first commit was made to the tree, so it's been around for a while. And it's been ever evolving, not always as fast as we'd like, but features are added periodically and things are being done. So I will talk about RAID in its entirety a little bit, and then we're going to go something Softraid. I'll debate a little bit how it works, just to underscore how incredibly simple it is. So the first question I usually get is, why in the world did you embark on doing yet another software RAID implementation? There are only about 20 of them. And that was a very fair point, but there's some reasons why I did it. So first of all, at the time I did RAID for a living. I still work at a large computer manufacturer, and I worked on the RAID team, and I was dealing with the RAID vendors. And it just basically piqued my interest, looking at their code and looking at the complexities involved. So I wanted to understand why and how a RAID stack would function if you would do it yourself. So, and I read many RAID implementations, and it's a lot of code, but nothing is the same as doing it yourself, right? Feeling the pain, having to put issues, debugging it. So, so that's what got me interested in it. So thirdly, I was really completely unimpressed with the other implementations. They're way too complicated, way too hard to understand. Even some of the open source ones were just way too hard. I mean, I'm not that smart, so I need some help. So, and worse, that we're actually completely not portable. So we'll get into some of these implementations later, but we'll work on i386 and x64, and then maybe on Mac, PowerPC, but that will be about it. So I never understood why. Why would you do if you do a software RAID implementation, why would you only want to limit yourself to one or two architectures? It's kind of boring. And actually, surprisingly, one of the biggest reasons why I wanted to do it is, again, I work with vendors, and these guys have 20 million lines of code for a RAID stack. And 20 million lines of code is a lot of code. In fact, I cannot even fathom 20 million lines of code. So in the world are these guys spending, thousands of man hours, hundreds of thousands of man hours, with hundreds of engineers writing millions of lines of code. And then you ask them, hey, can you change this a little bit? Well, that's really complicated. Well, obviously, right? If you have 2 million lines of code, something might have gone wrong along the way. So, who are you? So, I found out actually the other day, specifically for this, that apparently my title is that I'm a senior architect. I work for the Intelligent Data Management Group, which basically means all the fancy archival type technologies. So I moved on from the RAID team a long time ago. So and I've been working on stuff that I cannot debate right now, but it'll be coming out in the next couple of months. So when I wrote the code, I was actually working on a product that had basically a shelf of disks that was an external RAID implementation using iSCSI for transport. So before that, I worked in the RAID team, and I worked on SCSI and generic storage management code. And so working with RAID HBAs, I worked with a lot of vendors. I've seen a lot of code from these guys, and it was interesting just to say a few things. So I've been at this for quite a while, and again, that was all part of the motivation and why I decided to go and play with my own RAID stack. So, how did I get started? Again, so we talked about this a little bit, but vendors are basically hiding under guys on complexity. Everything is hard. Everything takes 2 months, 3 months, right? Oh, next quarter, maybe. A couple of quarters. That was always the answer. So I basically had to go prove them wrong. That was basically the itch that drove me. It's like, you guys are on crack. You guys are wasting millions of man hours doing stupid stuff. So, and again, talking to these guys, I mean, even the slightest bug fix would take a quarter. It was amazing. So, but they were always hiding behind how complex and how hard it is. Well, I kind of disagree. I mean, you're writing I/O, you wait until it completes, it either worked or not, and then you make a decision. It really isn't that hard. Did a proof of concept, and sure enough, I had basically a RAID 1 working in a couple of hundred lines of code. So, and at that point, I knew that that it was basically a bunch of crap, right? So these guys are lying to you. So let's look at hardware RAID. So most hardware RAIDers don't really speak SCSI, even though they are hooked up to SCSI disks, but they have their own little interface into it. So you have to write a driver that basically translates or proxies it to a SCSI implementation. So it's up to the driver writer to take basically the hardware vendor's API and make that look like SCSI, basically, for the operating system. So all the work is on the driver writer. And one thing that the RAID cards all do is they basically hide the physical disks from the operating system, right? Because we need to have full ownership, and you know the drill, right? You've heard that conversation from vendors 100 times. So, and all the I/O transformations happen on the RAID controller. So if you do, for example, a RAID 5, I/O comes in, it needs to go to X number of stripes, and it gets written out. So the transformation happens physically on the RAID card. And it's up to the driver again to make the volume look like a SCSI disk. So, and if you look at here, so here's the hardware piece of it, right? For the AMI, the LSI Mega RAID controller. Shows us a SCSI bus, which is, by the way, a fake SCSI bus that is being emulated in the driver. And then all of a sudden you see appearing the actual virtual disk, right? So this is a virtualization of a couple of disks underneath it. In fact, this one comes up as CVS, so this is one of the virtual disks that stores all our code. And one thing that we actually did on OpenBSD is we actually did expose the backend SCSI bus, and the only devices that we let through are the SES type devices. So SES are safety devices, and that's for picking up the environmentals. So you want to know if your shelf is on fire or not, that kind of stuff. We could actually even create the pass-through for the disks, and we could be able to expose all the disks, but the RAID card would not like that very much. But it could be done. So let's look at a virtual HBA, like Softraid. So since I started from a hardware RAID controller idea, I basically went after emulating that and basically doing what a RAID card would do in software. So that's where the whole idea came from. And actually, if you look at the dmessage excerpt over here, it should be pretty familiar. It's basically the same thing. Big difference being is that I'm obviously not hiding any disks from the operating system, right? So for the folks that have worked with Softraid before, you actually use partitions, and those partitions are what make up a volume. And that's then what's exported to the operating system. And another thing that was very interesting is that why would we stop at RAID, right? RAID was just a funny side effect, but we could do all kinds of really neat things because you got a virtual HBA. So you can do whatever you want. So one of the things we created, for example, was an encrypted virtual disk. Because at that point it was very, very simple. You already had a scaffold. You just needed to create your encryption discipline and move forward. It works in all architectures. And Theo might know the number on top of his head of what we support today. What are we up to, Theo? 16, 17? Not something like that. So we support about 16 architectures, and Softraid works in all of them, and it works pretty much the same in all of them. So I guess unlike the other ones that you played with before. Another thing I kind of skipped over, but so it is basically just like any other hardware controller, and it provides information just like a RAID controller would do via the sysctl, so the sensors in bioctl. So what about the others? So we had RAIDframe. We have RAIDframe in 3, but it's disabled. It's been disabled. It doesn't work on all platforms, right? That was the portability issue. So that's not nice. I mean, what if you want to run RAID on your VAX? You might want to. So I actually used some of it to read through it and get an idea of what they were doing, and I nearly went insane. There's the stuff happening up front, there's magic, and then something happens in the back. And I have never been able to trace that code. I'm just simply not smart enough to deal with research code. And it's pretty hard to use. They use a pretty arcane configuration file format to set up your RAID sets and reconstruct them. It's not simple. So we also have CCD entry. CCD is very, very unfriendly for the user. You do it wrong, you lose your data. It's pretty much the story there. It does certain things really, really neatly, and it's pretty quick. So it is a good model, but it's just not good enough, and it doesn't allow you to do fancy things like encryption, because it doesn't have the discipline mechanism. And also not good is that they don't use OpenBSD management paradigm. Sorry for that word. But I couldn't come up with anything else. But that is a big deal, right? Because we want everybody to use bioctl. We want everybody to use sysctl for everything you do. Not doing so basically means that you're different, and that's not good. And it's not actively maintained. So somebody give a hand for Ken for always making it compile again after somebody breaks something in the block IO layer. Because he's literally the only one that cares enough to every now and then commit to it. Let's talk about portability a little bit. So Softraid uses partitions, or chunks, as I call them in Softraid. And they use the type RAID. So that's actually kind of neat, because the RAID type already existed prior to me starting writing this code. So in other words, it was already integrated within the operating system. And I could use all the existing tools as they were without making any modifications. So that was pretty neat, because I could basically build on that. The bootloaders already were aware of it. All the pieces in the operating system, throughout the whole stack, can deal with the RAID type. As a side effect, I was able to make the code 100% machine independent. And that's why it's portable. So the only pieces that will be machine dependent are going to be booting and rooting, but we'll talk about that a little bit later. So partitions. So I will keep saying this because it's actually a pretty important point on how Softraid works and how Softraid is actually different from pretty much every other implementation. Is that we basically use simple partitions that you create with this label. And it builds its volumes out of that. So during boot, Softraid scans all partitions for SD and WD, and it looks for the RAID type. If they are the RAID type, they'll actually retrieve the metadata. The metadata is a reserved area on the disk, where you basically retrieve all the persistent information on a RAID volume, or a crypto volume, or a whatever volume. So if the threshold for assembly is met, right, so you got enough chunks for RAID 5 to bring it up, it actually is being brought up automatically. And if it is successful, that it's actually being brought up into the operating system, and all of a sudden you see the SCSI bus and the SCSI disk associated with that volume arriving in the operating system. So in this model, some pretty neat side effects. It gives us the ability to stagger RAID sets. So in other words, you can create a RAID 1, and on the virtual disk that you can create basically a crypto volume on top of it. Not necessarily a good idea, but you can do it. This is actually something that will require some additional work. We want to make this transparent, so that you can actually bring up staggered RAID volumes automatically as well. So in other words, when a volume arrives in the operating system, not only at boot time, you actually want to go scan again to see if you can find the metadata fingerprint on the disk that just arrived, and see if you can bring up some additional pieces. So there's actually some pretty complicated things that will happen in there, because if, for example, if you need to bring up 3 Softraid disks underneath to meet the threshold of bringing it up, right? You want to be able to bring up those 3 first before you bring up the next one, or else you're going to, for example, bring up a degraded RAID 5, and that would be not good. So this is a pretty complex problem that needs to be worked through. But currently you can do it by hand, and it basically works. So we can use all our external tools to access the partitions, which is pretty neat. So again, you don't have this luxury in hardware RAID. But I can basically hex dump my partition and make sure everything is peachy. Another thing is that Softraid is actually a really good kernel citizen. It plays by all the nice rules. Bob would disagree with me, and he would squeal like a pig about certain things that I do. And I'll touch on one particular thing that I do that he doesn't like, but there's simply no way around it. So let's talk about metadata a little bit. So the metadata that goes on a disk, it basically describes the Softraid volume, the individual pieces, and optional information that might or might not be required for that particular volume. And actually during a hackathon, and I'm pretty sure Theo can remember this one, we were very loudly debating where to put metadata. So where do we stuff it? Do we do it in the back or in the front? And there were some very good arguments on both sides of the equation, because there's pros and cons on both sides. A silly one, for example, is if you put it in the back, you don't have to, every I/O, do a plus operation to actually do the offset. Right? In an I/O stack, every instruction is an instruction, right? And it just adds latency to it. If you do it in the back, it's not easy to extend it. Right? So there were pros, cons, and in the end, we settled basically on stuffing it up front, because it was actually easier to do the scan. And booting actually would be easier as well. Because if you have a very large disk, certain BIOSes and certain other things can simply not read all the way to the end of the partition, and booting would basically be eliminated. That was actually the main argument for putting it up front, is that we wanted to be able to boot and root at some point of Softraid. So last time when I rewrote the metadata code, I made sure it's actually vendor independent. So what we did is we placed strategically located hooks that can translate the metadata on the fly. So if somebody is so inclined to, for example, do Intel matrix RAID, you could read their metadata. So you just simply have to write basically a metadata driver, but you could read their metadata. If they're doing a RAID 1, it would translate it into Softraid metadata on a read, and it would basically be able to bring up a Softraid 1, even though it actually is an Intel matrix RAID 1 software RAID thing. On writes, it's the opposite, right? So you translate the Softraid metadata into whatever the native metadata format would be. I'm going to skip that one for 1 second. So we version metadata. Every time you access the metadata, there's a counter in it that gets updated. So the reason for that is that you want to make sure that your metadata is always in sync. You don't want to have a failed disk. Let's say you have a RAID 5 with 5 disks, one of your disks failed, and you reboot your machine a couple of times without that disk in there, and then you put it back in there, and all of a sudden it would basically start participating again as a valid member. You obviously don't want that, because that would destroy your data. So to prevent that from happening, we version the metadata with every access. There's some variant and invariant parts to the metadata. So the variant parts are the ones that are always changing. For example, the versioning. The versioning number is a variant piece because it is changing literally every single access. The invariant parts are when you create a RAID 5, you know the size, right? So and that size is not going to change. So those are part of the invariant parts. So now let's get back to why metadata is so hard. So in the previous example, the previous talk that I was doing, I was talking about metadata as well. So apparently I'm not smart enough to deal with metadata, because metadata is always the hardest thing to get right. When you hack it up, it's all pretty simple, but once it needs to become generic and portable and work everywhere, all of a sudden metadata becomes increasingly complex. When I rewrote the vendor and the metadata and I did the vendor independent part, I spent weeks on getting that right. So it was a gigantic pain in the ass, and someday I need to figure out how to do this a bit smarter. Metadata sucks. All right, volumes. So those are the virtual disks that are exported to the operating system. So as we saw earlier in the dmessage excerpt, you see basically, as you would see with a standard RAID controller, you see it arriving. You see basically the volume arriving, and all of a sudden you can start using it as a normal SCSI disk. So the volumes are assembled for n number of chunks. If you're doing some sort of RAID thing, if you're doing crypto, you only need one. So it really depends. And the volumes are managed through the same tools as hardware RAID. So that was an absolute requirement, right? We had to have that. That was one of the main reasons to embark on this journey. So chunks. So these are the partitions again. We offset 8K from the start of the partition. And the reason for that is that actually I made a mistake. I had them pretty much all the way up front, and I was interacting with things like Spark64. Spark64 does not like for you to put metadata up front. Bad things happen. So what we did is we created a gap. That's the 8K that we're talking about. Then we drop a header down. We drop the volume information. And then we put all the chunk information. And we have, for example, in crypto, we have optional metadata that carries the keys, or the encrypted keys, I should say. Then we have another gap. And then we have the data area, which is basically where you actually end up writing to. Another interesting thing to mention here is that this is tiny. We're talking about bytes total to do the whole thing. Hundreds of bytes in a large RAID set, easily below a K. If you look at some vendors, they have 8 megabytes in front and another 16 megabytes in the end of the disk to describe their RAID sets, because apparently that's very, very hard. And again, also the chunks are externally visible because they're just partitions on disks. So if you want to punish yourself real good, you take a single disk and you create a RAID 5 out of 10 partitions. It's up to you, right? You can shoot yourself in the foot royally. All right, this is what we currently have in the tree. We have a RAID 0, that one is basically finished. We have a RAID 1, that one is basically finished. So that one does, these days, rebuilds, auto rebuilds. It does everything. So you can rip a disk out, insert disks, all the things you would expect from a normal RAID set. The one difference that I did with RAID 1 is I never understood why RAID 1 was 2 disks, right? I would like to have a 21 disk RAID 1, right? Who are you to tell me that I can't? So in Softraid, the RAID 1, you can create as many mirror pairs as you want. So it might sound silly, but all the reads are interleaved. So what you'll get, you can actually spread your load over a wide variety of disks. So if you do a whole bunch of reads, this could actually be a nice performance gain if you're willing to pay the storage price for it. The writes obviously are going to not be as good, right? Because now you have to complete the 21 writes, 21 times the same thing, to 21 different disks, and that's obviously going to add a lot of latency. But again, it's good for certain things. So RAID P, which is basically RAID 4 and 5. So the reason why it's called P is for parity. The reason why you call it the same thing is because the algorithm is identical. Where in RAID 4 you basically have a fixed disk, and on RAID 5 it's always it's interleaved on all disks. So this is one single discipline that handles both RAID types. RAID 6, also basically working. So RAID 6 has parity and ECC data, so you can lose up to 2 disks and still reconstruct the data. This is incredibly complex. So this was written actually by Jordan Hargrave because he was bored apparently. All of a sudden I got a diff in my email. It's like, yeah, try this. Well, that's cool. Not very fast on the slow systems. That was the first thing that I noticed. In a word of caution, so these ones, Marco has not written the scrub yet, which is relatively simple. I just haven't had the time to sit down and do it. So in other words, when you start your, when you create these disks, you would have to actually scrub them. You need to make sure that the parity is set to 0. And currently we are not doing that. So if you have garbage in there, you're just going to, you cannot basically perform a reliable rebuild without zeroing that data first. So that's something that needs to be done, and somebody needs to write it, being me. And once that is done, we will be able to actually move on into the rebuild part. Jordan actually wrote the rebuild code, but it's obviously not going to be reliable. The crypto discipline, that one's pretty much done. Lots of people use that one because that one's fancy, right? You create your /home on software RAID with crypto per the thing, and the rest of your disk is just standard stuff because you don't care as much. We get a lot of complaints about performance measurements, right? People run some silly tests against it, and yes, it runs slower than a regular disk. I mean, it's a surprise for everybody. But I use it daily on my own /home, and I don't really see any appreciable speed difference in normal use. I know it's slower, but I don't get to see it as much as a lot of other folks do. So we have an AOE one, ATA over Ethernet, disabled currently. It kind of works, but that one needs a little bit more work. There's one interesting thing about AOE is that actually we are doing something different with AOE than we do with the standard Softraid stuff. So what we do over here is we have a client and a server. So the client is actually a standard Softraid discipline, right? So because it goes out there, discovers the AOE target, and brings it up into the operating system. You see the SCSI disk appear. On the target side, you do not have a disk that appears in the operating system, right? You are going to claim that partition that contains all your data, but again, it's not an actual disk that you want to be able to use. So some modifications were actually made to the metadata to accommodate that, so that you can claim a partition even though you're not going to export it as a disk. So that is what's going to enable other types of target devices. Each one of these disciplines owns exactly one volume. So as you bring up one of the disciplines, one volume will be associated with that one discipline. You can create another discipline with another volume, but it's going to be a different instantiation inside the kernel. All right, let's follow a front-end I/O. So this little chart at the bottom is mostly accurate. It's I simplified it quite a bit, but it should just give you an idea on how an I/O, the front-end I/O as I call it, so an I/O from the operating system as it flows into the through the kernel. So as it flows down, right, so you have an application writing to some sort of file system, goes through the block I/O layer, hits the SCSI mid layer, and then Softraid sits there pretending to be an actual HBA. So in a RAID type discipline like RAID 1, Softraid actually goes back up the stack, goes to the block I/O layer, which then in turn goes through the SCSI mid layer, goes to an actual storage driver where the partition resides, and then it writes out to one of the chunks. So, so an I/O can go basically all the way up and down and traverses all the way back. So as you can see, it gets complex pretty quickly. So let's talk about work units. So work units are the things that that wrap around a front-end I/O. So as a front-end I/O comes in, a work unit is wrapped around it, and you calculate how many CCBs you need, so command control blocks. These are physical I/Os, right? So this is basically the fanning part of it. So a work unit has direct pointers to all the I/Os, but it also has a linked list on the I/O so that you can easily traverse them and do some magic to it. So as the individual I/Os complete, they go back to the work unit, and then once you complete all the required I/Os, you're going to complete the work unit, which again, in turn, completes the front-end I/O, and it traverses all the way up the stack. So an interesting feature that I built in there from the very beginning is a thing called collision I/Os. So collision I/Os shouldn't happen, by the way, but I'm glad I actually wrote this code because it has come in handy for different things. But basically what happens is if you have two LBAs that are overlapping, or sorry, two I/Os with an LBA range that is overlapping, the overlapping I/O is scheduled right behind the first I/O that was created. So in other words, what will happen is if you have 100 I/Os that are all writing to LBA 0, you basically would create a chain of I/Os that are going to be executed in the appropriate order. And the reason for that is obvious, right? Because you don't want to have a random order writing to some block somewhere on the file system. Although even though the file system code actually prevents that from happening, I thought it was a good idea to just have that additional protection. So a very nice side effect of this is actually you can create atomic I/Os, if you will. So the mantra of Softraid is embrace the race, right? Because there is nothing you can do to prevent all the races that exist. So, but having this collision mechanism, for example, we use it in RAID 5, in RAID 6 quite a bit. So if you miss one of your disks, what you want to do is you want to be able to read the next number of disks And once that completes, you know all the pieces you need to read the next portion and then reconstruct your data. So in the collision mechanism actually provided exactly that same functionality. So it came in very handy to have it. So CCBs, we talked about it a little bit. So each physical I/O is wrapped in a CCB. So this is where Bob squeals. So what I did is I basically when I created the structure, I created the buff structure is the very first field of the CCB. And I have to do that because the CCB, the only thing I can complete is a struct buff. So that is what I'm going to get out of the interrupt handler. So I had to fake it out and basically make sure that I provide the buff with all the additional information that Softraid needs to be able to go back into the discipline and figure out what it's dealing with. So there was really no way around that. And in fact, reading all the other RAID implementations, Softraid, and in different operating systems, everybody uses pretty much the same trick. Actually, recently we switched everything to the vNode API because we ran into some issues where you could actually have multiple. You could actually have, I forget exactly what it was. Do you remember? It was like a disk label, and if you ran that, then it would decrease the usage counter. And at one point, you would lose the ownership of the disk. So that was bad news. And using the vNode API actually keeps the usage counters or reference counters correctly in order. So what's the future? Well, we really want to be able to boot and root off Softraid. There is some code that exists. Actually, some of it is already in the tree. Joel Singh wrote all this code. And he has a booting Spark64 off of Softraid. Even though Spark64 seemed like the ideal candidate, it actually wasn't for different reasons. But because we expected actually with the advanced firmware mechanisms that they have, that you could actually, that we would have all the pieces required that then we could later model within the other architectures. But you can actually not uniquely identify a disk using open firmware. So it stalled because of that, so we haven't moved forward on it. But basically what it's going to do is we are going to add additional optional fields to the metadata to do the identification for us. So we'll put the smarts in the metadata instead of using open firmware for it. So a lot of people want this, obviously, and one of the bigger things that people want are booting off of a crypto volume. I'm not really sure if I like that or not. It's neat, right? And being able to do that is obviously something I cannot argue. So there's still a few disciplines that I would like to write. Sorry, Claudia. But the reason for Softraid was, at the very beginning, was to go do my own iSCSI implementation. And then Claudia took the spotlight on that one. I need a concat one, so where you can basically just add another disk to it, so you can grow disks as you go. So that would be very handy in certain scenarios. I might dab in FCOE. The real big iron is all transitioning to FCOE. So if you want to play with those, it would be pretty neat, obviously, if you can do a discipline. Although this code is going to be extremely complex because it's all committee stuff. I also want a cache discipline, and that could be used, for example, as a. So this is where staggering actually comes in. So we would stagger, for example, a crypto discipline with a cache discipline. In other words, you would complete an I/O way before you actually commit it to disk and do the encryption on it. So that's another thing that's basically sitting in my mind of what I would like to do. So you say, for example, okay, I want to reserve a gigabyte of RAM, and I'm going to do some nice caching stuff on that. We need a scrub. We really, really need the scrub. Because that's basically what's preventing RAID 4, 5, and 6 from being workable. Another thing that actually is pretty important, even though it's not a Softraid feature, again, Joel worked on this one, but we need to be able to mount by ID. That's turning into a big deal. And Softraid just exacerbates that problem. So we need to be able to say mount 0x555678 instead of SD4. I'm sure most people have run into this one. In the Softraid, this can be a really pain in the butt, especially if you have roaming devices and your partitions are all jumbled. If you dealt with this one, you know the pain. All right, these are the people that have worked on it. So thank Henning for this beautiful picture. I will not go into the reason for this picture. The people who know me from OpenBSD know the joke. So there's a bunch of folks that have worked on this. Joel has done a whole lot of really clever things. He's done a lot of really neat things. He's the one working on routing. He's working on the mount by UID. He has done a lot of good stuff. Ted, as usual, writes something and then disappears. So he wrote the AOE thing and then ran off. Unpronounceable. He wrote the crypto discipline. Damien Miller actually helped a lot when we were rewriting the metadata. We just sat for a couple of hours at a hackathon and hammered that out and figured it all out and did that. Jordan just is insane, and all of a sudden RAID 5, 4, and 6 appeared in my email because he was bored. So he has done a pretty huge amount of work on it too. So again, thanks everybody for putting up with me and letting me come over here and visit your beautiful country and eat some of the best food I've ever had. It's been great. Any questions? Yes, sir.
You mentioned that some of the other implementations, the commercial ones are 20 million lines of code or so. What's Softraid up to now?
Shoot, I wrote that down. With all disciplines, like 18,000 lines of code?
18,000.
So that includes all the disciplines. So the biggest piece of code is Softraid.c, which is basically the scaffold. And that one is roughly 10,000 lines out of the 18,000. And out of those 10,000, probably 4,000 are metadata. Just to underscore the differences there. Actually, I have the real numbers if you wait 5 seconds. I saw another question pop up while I'll type. What was that? And I'll answer you correctly. What was that? What was your question?
Yeah. Is there some plans to combine a few layers inside the same volume? Several processing layers, I mean, in this case, in this situation, to build RAID 10, you will need to have 3 SCSI mid layers. It's significant overhead, I think.
Yes, that is an issue that we are aware of. And again, we are not sure how we're going to do staggering yet. There are some different plans. You're absolutely correct, actually, on that one. So that is part of the let me click here for a second, but that is part of the issues that we are dealing with. So how are we going to do this? So one of the ideas is, you know what, some of these RAID sets, like a RAID 10, you just want to have a RAID 10 discipline. But having a RAID 1 plus crypto, staggering becomes all of a sudden a lot more interesting, right? Because that is uncombinable, really, right? You cannot come up with a generic enough framework that would literally combine those two things into one. So it's going to be probably a mix and match of both technologies, or both methodologies. So RAID 10, yeah, we'll probably just write a discipline. Crypto plus 1, that'll probably be a staggered one. And this where caching again would be pretty neat to have in that whole entire stack. So you can actually cache a whole bunch of this data and get some nice speed ups.
Is that actually what Geom on FreeBSD does, just without
I was wondering what the question was.
SCSI mid layers?
Mm-hmm. Yeah, Geom does some interesting things. Geom does some things that I don't like at all. That's why I didn't venture into that particular thing. I did read some of the code. It's not portable enough, and it required some user space changes that I was not a big fan of. So let me find those. I promise I have. Look at that. Those are the actual numbers, because I did write them down in my original presentation that I ditched, actually. So 10,000 lines code total, sorry, 10,000 total. 4,500 in the framework, so that's Softraid.c. Crypto is the biggest discipline with 1,400 lines, and then RAID 0 is the simplest one, which should also be the reference one if you want to write your own. That one is only about 500 lines of code, including license, by the way, all these things. So RAID 1 is about 600. There's all the niceties like pre-builds and that kind of stuff as well. RAID 4 and 5 is 900. I didn't look at RAID 6 for some reason. I don't know why. And AOE is 1,000. So as you can see, it's pretty minimal. I mean, it's orders of magnitude smaller than what some of these crazy vendors are doing.
So how is it that you're able to do so much with such little code compared to the other commercial?
Well, what happened in the commercial RAID stacks is that they have been bought and rebought and resold and resold again, and it's always the same thing, right? You just craft more crap on top of it, right? Because you're not going to touch the internals, because the new engineering group doesn't know how it works, and they don't dare to touch it, right? So they'll just keep adding on to it. So if your RAID stack is all of a sudden 20 years old, and it has been owned by about 5 vendors, you'll have 20 million lines of code. Adaptac, as an example. They literally have 20 million lines of code. It's insane. It's unreadable.
About AOE, is there some reference implementation? So what you was working with?
There is the... Oh, so first of all, it's not an actual spec, right? It's was some guy who decided to go sell his little AOE product, and then he wrote his own RFC, which wasn't the real one, but we basically used that thing. There are about 4 or 5 implementations out there. So we used the Linux one as one of the models, and we were actually able to run some I/O. Although it needs some love, though. That code has rotted for a while now.
Is there any benefits against iSCSI? So why do you implement AOE but not iSCSI?
AOE is much simpler. Much simpler. And there's actually some good things about AOE. AOE is Ethernet, right? So you don't route. So that can be good or bad, right? So it really depends on your implementation. And again, it's incredibly simple. So the whole thing, basically client and server, 1,000 lines. iSCSI is going to be probably in the thousands of lines of code. How much are you up to, Claudio, on iSCSI?
The DRAM is currently about 2,000 lines of code.
See, so that is the difference, and then you don't have your initiator yet. And by the way, the hard part in iSCSI is going to be the initiator. The target is quite simple. Any other questions?
With RAID 5 and 6, do you have some education or other mechanism to make writing at least somehow reasonable speed?
As long as it's not broken. That's really the trick. So RAID 6 really drops in performance once you have a disk broken. If you want to see it completely fall apart, you rip 2 disks out. Because now
I mean the situation of short write, when you need a read modify write situation. So
well, so you are going to pay that price. There's just no way around it. This is again where a caching discipline would be very handy, where you can win some of those back. But the read modified write is multiple IOs that have to complete in a certain order. So you will take the latency hit, right? Because you need to read some crap off of the disk, modify the bits, and then write it back. And there's simply no way around that. Unless you know some fancy mathematics that I don't. I'd love to hear it. Any other questions? Yes, sir.
When is the key disk working?
Key disk is working.
Is it working?
Yes, key disk is in. So the only thing it doesn't do, okay, let's talk about key disk. So the OpenBSD folks know this because everybody wants it. But key disk is one of the coolest features actually that we have in Softraid. What it is basically you have a USB key which contains your crypto keys. And what you can do now is you can boot off of your machine with that USB key in it, and all of a sudden your software crypto can now be brought up as you boot. Right? And if you don't have the keys, you cannot. So it's a very cool trick to basically have your keys on, basically hanging around your neck, and you boot your machine, your disk arrives, and then you can yank the disk out and walk away and still have the disk. So the portion that we don't do yet is the automatic discovery of the key disk. And so all the pieces are in place actually. That code just needs to be written. So the last hackathon, Theo allowed me to put in a crazy hack to find every arrival of disk in the operating systems. In other words, you insert a USB key in any disk in an OpenBSD machine, and Softraid actually gets a call saying, "Hey, there's a new disk. You want to look at it?" So the deployment is all in there.
No, there's all the partitions of that disk.
That's right. Sorry. Yes. He was right. So it looked at all the partitions on that disk. So if you have, I mean, you can bring up all kinds of really cool things with that. But the use case is dual, and there's going to be several methods, right? So you're going to, some people want the keys to still be encrypted on a USB key, so you still have to type a password, even though you have your USB key. Another thing is we want is when you yank the USB keys to partition, is that that you quiesce the I/O in that disk is basically no longer available, which is pretty cool too, right? Because now somebody scary walks by, you just yank the disk and you run away, swallow it, something. So one thing that I actually did not mention at all is that Softraid crypto is actually very border friendly. So for the people that might suffer from having somebody take an image of your disk, it doesn't appear in the operating system unless you tell it to. And again, to do it automatically is where the key disk came in. So if they force you to actually power on your laptop and for them to look at your things, what you can do, in fact, I have it on one of my laptops. I have a fake home partition that comes up if I don't do the magic up front. So in other words, it seems like a well-working machine, a normal operating machine, but it isn't, because my real home is actually sitting on an encrypted partition. But you don't see it when you boot. So even if you have somebody who's intelligent at border patrol, come on, let's all laugh about that one, but you basically can get away with a lot of really neat things. And another feature that some people don't call it a feature, I really do, is we have a kill switch as well. So if you bring up a Softraid crypto with force, it will overwrite the keys. So in other words, you can destroy your data instantly, right? So if you come into some sort of, you're trying to hide or your child pornography, you can get away with that. Because you can just hit the kill switch and everything is gone. Right? So obviously making an extreme example, but it is neat that we basically have those little features in there. Softraid crypto is really, really cool, actually. Yes, sir.
So with pulling the USB key, are there plans to flush the keys from memory? Because there's those cold boot versions.
Well, obviously. Right, so that would be the first thing you do.
Okay.
Or else it would not make any difference. But you need to quiesce I/O first, right? And you can conceivably do it multiple ways, right? You can literally remove the volume completely out of the operating system as you yank it, right? So that if you have applications running, they will fail. If you quiesce I/O, it's a little bit friendlier, but then your volume still physically exists in the operating system, right? But you can just not read or write to it until the key gets reinserted. So there's certain levels of things that are interesting that could be done with it, and I think that we're going to have a couple of knobs there actually to be able to enable all these kinds of things. So all of them are neat. Any other questions? All right. Thank you for your attention.